Okay, as I mentioned earlier, in order to do a rotation or to define a rotation, there's some information we need to know. We need to know what is the center of that rotation, what is the direction of that rotation, and what is the magnitude of that rotation. Well, when we do two reflections to get our rotation, the two reflection theorem for rotation kind of gives us all of that information. Okay, it says if M intersects L, so if those two lines intersect, the rotation of the reflection over M following the reflection over L has a center at the points of intersection of M and L. So the center point is where they intersect. Has a magnitude of twice the measure of the angle formed by these lines. Okay, so whatever the angle formed by the lines is, we're going to double it to get the magnitude of the rotation. And it will always be in the direction from L towards M, or from the first line of reflection towards the second line of reflection. Okay, so all three of the pieces of information we need to know about rotation are contained within that two reflections theorem for rotation. It tells us the center, which is the intersection point. It tells us the magnitude, which is always going to be double the measure of the angle between the lines. And it tells us the direction, so it's from the first line towards the second line. So let's take a look at example 2 here. It says, describe the center and measure an angle to determine the magnitude of the rotation for the reflection over T following the reflection over S. Okay. Well, we don't even have a figure here to rotate, but it really doesn't matter because we have all the information we need from the two reflections theorem. Okay. So the center of the rotation involving these two lines, okay, this composite, would be at this point, point Q, where the two lines intersect. Okay. The magnitude of that rotation is going to be double the measure of this angle, and it's going to be in a direction from S towards T. Okay, and when I go from S towards T, what I'm doing is I'm going over the acute angle. Okay, so this is my smallest angle, so I'm going across that smallest angle from S towards T, and you'll notice that that is a clockwise rotation, therefore my direction is going to be negative. So we have a center at Q and a magnitude of negative 60 degrees. When we express the magnitude that way, it takes care of both the direction and the number of degrees of that rotation. Okay, let's take a look at example 3 then. It says triangle H prime, I prime, J prime is the image of triangle HIJ under a rotation about point Z. Using a protractor and a straight edge, create two lines, A and B, such that the reflection over B of the reflection over A of triangle HIJ is H prime, I prime, J prime. Well, first thing I'm going to do is I'm going to remember that this right here is the same as writing it like this. The reflection over B following the reflection over A of HIJ is its image, the image of HIJ. Okay, so if I'm going to draw in those lines, I have to first figure out those three pieces of information that I'm looking for. Number one is what is the center of the rotation? Well, that's Z. If that's the center of the rotation, I also know that's where my two lines A and B are going to intersect. Okay. Number two, I need to know the direction that I'm going to be rotating. Well, I'm going to be rotating in the direction that is clockwise, therefore I'm rotating a negative direction. Okay. And finally, I need to know what the magnitude of that rotation is. And to find that magnitude, what I need to do is I need to take a pre-image point, the center, and an image point, and measure that angle. So I'm going to start by drawing in rays from the center point through the pre-image point. Okay, and then I'm going to do the same thing going from the center point out through the image point. What that does is it gives me an angle that I can measure, so I can see what kind of a rotation I have. So when I go and I look and measure at that angle, it looks as though I'm getting an angle at about 66 degrees. So what that means is that that figure was rotated 66 degrees. Okay, therefore the magnitude of my rotation is negative 66 degrees, because we said we're going from the pre-image to the image. The direction of that rotation is going in a clockwise manner, therefore it would be a negative rotation. Now what that tells me is that if my magnitude is negative 66 degrees, when I draw my two lines, they have to be drawn in such a way that the angle between those two lines is 33 degrees. Okay? Okay, so I don't really need these rays that I drew here anymore, because all they were there was to find out what the magnitude of that rotation was. Now I know that I have to draw two lines with a 33 degree angle between them. It really doesn't matter where those lines are. So if I draw my first line, okay, and it doesn't matter as long as it's a line that goes through point Z, we're okay. Okay, and I have to draw another line now that is a 33 degree angle. Now, if this is my line A, my line B has to be clockwise from that, because remember our rotation was clockwise. So what I need to do now is I need to, from this angle, I need to measure clockwise 33 degrees to find out where I'm going to put my second line, my line B. So I'm going to use my protractor now. I've got my protractor on with my center at Z. I'm going to measure 33 degrees from this line in a clockwise manner. Notice how I have my protractor set up. So 33 degrees, here's my line for 30. So 33 would be about right there. And then we can take our ruler away and we can connect those points to form that line. So I'm going to go ahead and draw a line that has to go through this point and through Z. And we have our two lines, this being line A and this being line B, where this angle right here is 33 degrees.